So, laser tests are quite a thing in flat Earth community. If you look on YouTube, you can find plenty of laser tests by Dr. Sack and by Doria Daka or Jeranism. And a lot of these tests claim Earth is flat, or claim the previous tests have been debunked and Earth isn't flat. So I've been looking into this, and I found Jeranism to be quite active with performing laser tests. He's done several over the past couple of years. He was supposed to do one on the 25th of November, according to himself, but he hasn't released any results yet. The way he wanted to do it was quite complicated as well. So I'm basically thinking he set himself up to fail with his test. So looking at it, I decided, well, why don't I design a test myself? Make it really simple, make it easy for people to repeat the test with only a few necessarily pieces of equipment. And well, I just went out and found myself a nice little location to perform this test at. I found this. This is a small canal. It's about 1.3 miles long, and it has two bridges on either side, so it provides access to the water, so we could set up the laser at water level and then see or measure if the Earth is curved or not. So this is the bridge on the east side. The canal is going that way, and we could gain access to the water here, set up the laser and shoot it across the canal. This is the canal. It's nice and small, so it doesn't have any influences by wind, so you don't get lots of waves. The concrete bridge here allows access to the water level as well, so you could set up a nice little target here. And halfway here we have power lines, which are about halfway, so we could use those as an indicator for the halfway point, and then set up a target in the middle to perform some measurements there. I've already calculated something based on measurements taken in Google. So the distance is 2.12 kilometers or 1.32 miles, and the drop should be 35 centimeters, or I think about 14 inches. This should be enough for an accurate reading and determining if the Earth is curved or not. This is the way you would normally take this measurement. You'd set up a laser horizontally, shoot the laser beam across the surface, and over distance you would measure the increasing height to determine the curvature. Now this is really difficult because the curvature is about 8 inches per mile squared, and we're just over a mile, so the declination would be about 0.0129% or 0.0116 degrees, which is really tiny, and you can't really measure that with a normal water level. So we need to adapt the measurement, and we're going to do this by adapting the way of testing. So what we're going to do is the following. You can see the view height here, which will be the height of the laser, is going to be 9 centimeters. At the other end, the target is going to be at 9 centimeters as well. So we could measure a horizontal level, and the bulge in the middle should exactly be 9 centimeters. So by firing the laser across the water from 9 centimeters to a target on the other end at 9 centimeters, it should skip the water level in the middle, and just hitting the water without changing the direction of the laser beam. This is the way it should look. So, and we can measure this, so 9 centimeters at one end to 9 centimeters on the other end, just hitting the middle. This should be a way to accurately measure the curvature of the Earth. There's only one concern I have, and that's the laser itself. The laser beam at the laser is 5 millimeters, but over 2.12 kilometers, based on some measurements I've taken already. It should be about 6 inches. So you'd have a laser beam that gets wider over distance. There's a way around this, and that's by focusing on the edge of the laser beam, and by tilting the laser just a bit, we could get a horizontal line across the surface, so we can measure 9 centimeters above the surface here to 9 centimeters above the surface here, and just focus on the outer edge of the laser beam. This is the way it would look. So this should solve the problem with the widening laser beam, and should be able to get accurate readings at the middle, determining if the Earth is curved or not. Well, all of this of course is just fooling around if we don't document this. So for documenting the results, I've made this. It's a small sheet to document some readings we've taken, to check the readings after the test and recalculate if the actual measurements comply with the calculations we've made up front, or if we use different distances or different heights, we can calculate afterwards if the math is exactly the same as the readings we've taken. If we can compare the both, then we can determine if the test was performed accurately. So what we're going to do is we're going to document the air temperature and the water temperature. This is important for refraction. If we can see refraction, we don't know if it's going to influence the test itself, but we could perform the test several times over different days and then see if the refraction due to different air and water temperatures is going to influence the test itself or influence the results. Important also are the measured distances and the measured heights of the laser and the targets. If we can't use the distances or the heights, that's not a problem, but we'll need to check if the math afterwards with the information from the actual distances and heights will confirm if the measurements are okay. So just by documenting it, we can make sure the test is performed accurately. I've also noted the equipment specs. I've got a 200 milliwatt laser. This is the only thing I've actually bought. All the other stuff is just homemade or phone cameras and just regular video cameras. Just to show you how simple this test is going to be, I've set up a little rig in my office just to be able to show you what the test is going to look like. So on my desk here I've got my 200 milliwatt laser. I'll just turn it on. It's now going to shoot a laser beam across my desk, and it's going to not hit my 2-foot globe, but it's going to hit a target here. It's a single sheet of plexiglass, and it's going to give a nice round dot from the laser beam, and about halfway here I'll be putting a single sheet of plexiglass in between, and as you can see it's a single dot, and it really doesn't change the laser point on the wall. It turns it into a star, but it doesn't change direction or shape in any way. So with a single sheet of plexiglass in the middle, we can perform a test. I've also got a double sheet of plexiglass, and the same thing happens. So the laser shines on the first target, and it hits the second target without changing its shape or direction. It turns it into a star, but it doesn't influence anything of any importance. So basically, the plexiglass should be just a regular good tool for performing this test. So this is the way I would perform this test. If you have anything to add, or you just have some tips or other comments, just let me know. And based on that, maybe I'll redesign the test. I don't know yet. And then in a couple of weeks, I would like to perform this test and show you the results when I've got them. Thanks for watching.